Have you ever wondered what is that teeny tiny number on the top? I'm here to simplify it for you. My name is Mahmoud Kiazari and welcome to my channel, Special K. So without further ado, let's just talk about it. Power. What does that mean? As we all know, just power is a physical concept or maybe electrical concept, but in math, power means that one number on the top of another number. So just look at the screen that we do have a very simple example, 5 to the power of 3. So 3 is means that something on the top, and after that we do consider the whole package as the power. We call one number as a base and another one as exponent. So what does it actually mean by power? Imagine that you do have a scenario that you have to multiply 5 3 times by itself, right? Well, just let me write it down for you. 5 multiplied by 5 multiplied by 5. So in this scenario, it's not that hard. I mean, 3 times of 5, okay, it would be 125. It is simple. But imagine that I would ask you to multiply 5 10 times by itself. So you would say that, okay, obviously just writing it, just finding the calculation, it would be so hard. And also about the writing. Imagine that you have to multiply 5 10 times together. How can I write it down on the paper itself? At this point, we are saying that if you do have a number that you're going to multiply by itself so many times, or maybe a small number of times, or so many times, you use the concept of the power. Power is the repetition of multiplication. If you remember that, we had the definition of multiplication. What was that? For instance, when we are talking about 5 times 2, we are talking about multiply or adding 5 2 times by itself. We do have the same concept about the multiplication, and here we are here in order to just simplify it for you. So let's just talk about it. Why, again, we are using power? Because power is everywhere. Power is a way that we can simplify the big numbers or very small numbers that we will talk about it shortly. For instance, when we are talking about the storage of your phone, we are talking about the power. When we do have a 32 gigabytes, it's actually 2 to the power of 35 bytes of memory. When we are talking about compound interest, we are talking about the power. We are talking about the bacterial growth or any other kind of phenomenon or any kind of accident or incident that you have around yourself is based on the power. So let's talk about the wordings again. If you remember, I told you power is a package. We do have a number that we call it as a base, and after that we do have another number that we call it as exponent. So what is the base again? Base is a number that is being raised to a power, right? So it means that what is that specific number that I'm going to multiply it by itself? In our scenario, when we have the 5 to the power of 3, my base is 5, means that the main guy over here is 5, that I'm going to multiply by itself. So I have to know how many times, right? So we do have another thing that we call it as an exponent. What is exponent? Exponent is the small raised number that tells how many times to multiply the base by itself. So at this point, 3 would be the base itself. And what is power? The whole package is considered power, that we know it as 5 to the power of 3, or at this point we use wordings because now obviously not all the time we're talking about 5 and 3. There are so many times. A to the power of n. A is your base and n is the power itself. So how we can read that? 5 to the power of 1 or 5 to the first power. 5 squared or 5 to the second power. 5 cubed or 5 to the third power. These are very common names. I mean, you don't have to memorize it, but at least I see these ones just in case if you look at some kind of texting or any kind of other kind of videos. But I believe this video is enough for you. But you at least know what is going on. But again, 5 to the power 1, 5 to the power 2, 5 to the power 3, and etc. would be completely right. So let's move forward and again, visualize this condition. Imagine that I do have a condition that I would like to multiply 3 4 times by itself. What do I have? Either I can write it down like this, which is going to be time consuming and so long 3 multiplied by 3 by multiplied by 3, 3 to the power 4, and I do have 81. Or I can write it down like this. So from now on, if we are dealing with repeated multiplication, we are using the power. We do have the same scenario over here, 10 to the power 3, it would be 1000. The one hint on one trick about the 10 is that you don't have to do so much of work. Why? Because whenever you have 10 to the power of n, means that you only have to write down 1, and based on the number of n, you can just write down 0 by the side of 1. 0, 0, 0, 0, whatever the n is. 10 to the power 1, 1 and 0, 10. 10 to the power 3, 1 and 3 zeros, 1000. So this is another hint for you, because sometimes I saw students that have some confusion about this part, is what was the definition of multiplication and what was the definition of power. So whenever we do have multiplication, means that one number is just adding by itself. 5 times 3 means that 5 is adding by itself 3 times. 5 to the power 3 means that 5 is just getting multiplied by itself 3 times. So try not to get confused. So let's talk about the rules, obviously, like addition, subtraction, division, the 4 arithmetic operation that we have. Each of these concepts, especially the power, has some rules. So today we are going to talk about some of them. Again, there are so many rules about the power. We are not going to cover all of them, but we are going to cover the basics. And I believe you don't have any problem with the rest, because if you understand this, the next ones would be derived from these ones. So product rule, what does that mean? Imagine that you do have a scenario that you have two powers. One is a to the power m and another one is a to the power n. So in order to simplify it, 2 to the power 2 and 2 to the power 3. How I can multiply the powers together? Obviously, the very easy way is just 2 to the power 2 is 4, 2 to the power 3 is 8, 4 times 8 is 32. It is so simple, it is completely right. But imagine that you're dealing with big numbers, 2 to the power 10, 2 to the power 30. How would you like to do that? Still, you want to find the answer based on your calculator by multiplying 2 10 times by itself? So no. At this kind of these questions, we do have a way in order to multiply powers by each other. How? It means that when you do have same base, you see that I do have 2 and I do have another 2. I do have a and I do have a. And if you have different exponents, you can keep the base and add the exponents. At this situation, I do have a to the power of n plus n. At this condition, I do have 2 to the power of 5. I keep the base, and after that, I added the exponents. 2 plus 3 is just 5. You can use the calculator right now, see that 2 to the power of 5 is right or not. Let's see another example. 2 to the power 3 multiplied by 2 to the power 4. Either I can find the 2 to the power 3, which is 8, or find the 2 to the power 4, which is 16, multiply them together, or there's another way that I can just keep the base, add all of those exponents with each other, and keep the value. Sometimes the question would be given you like this, and after I would say that find a final answer. They're not specifying that final answer should be a number or power. At this kind of scenarios, I would really recommend you to keep the power itself, because it's going to be so challenging if you want to find the final answer. Yeah, I know in some kind of these days calculators, they do have exponents, but try to keep it that way. If they ask you, you can use it. Okay, so now let's have a question for you. 5 to the power 2 times 5 to the power 3. Just stop the video, think about it, just look at the whole scenario and the rule that we have and try to solve it. I believe you did it right. 5 to the power 2 multiplied by 5 to the power 3 means that I have to keep the base, add exponents, and I do have 5 to the power 5. Easy. Product rule. Let's move to another one, quotient rule. What does that mean? As we have rule about the multiplication, we also have rule about the division. Imagine the same scenario, but this time, instead of multiplication, we do have division. It means that I do have two numbers, both of them are in powers, a to the power m and a to the power n, and I would like to divide them together. What can I do? Simple. Again, keep the base, but this time, instead of adding them, I just subtract them. It means that division just converted to subtraction, and multiplication just converted to addition. Simple. So let's see an example. 7 to the power 5 divided by 7 to the power 2. Keep the 7 and subtract 2 out of 5. 7 to the power 3, 343. You can also find those numbers one by one, divide them together, and you see that you would get the right answer. So that was the step by step. I talked about it. Again, remember, when we are talking about the product rule and the quotient rule or division rule, we have to consider the fact that base should be the same. It means that if I'm at the scenario that my base is not the same, I cannot do that. I've seen thousands of times students just forget about it, and after that they ruin everything. Remember, in mathematics, just simple problem could lead you to a completely wrong answer. So let's talk about the third rule. It's about the power to power and distributive rules. What does that mean? Imagine that you do have a scenario that your power is inside another power. So say that, what is that supposed to mean? Imagine that I do have a case that a to the power m, and after that the question would ask, okay, use an exponent for this one and use it inside another power. You would say that, okay, that is so silly, but no, we are going to use that. So how am I going to simplify it again? The motto and the rule of our work is we are trying to simplify everything. A to the power m to the power of n. How can I simplify it? Easy. I do have the parentheses. At this point, I can multiply the second exponent by the first exponent. Imagine that I do have 3 to the power 2 to the power 4. Instead of just writing it down as the way it is, or writing it down as 9 to the power 4, I can multiply the 2 by 4. I do have 3 to the power of 8, whatever number is that. Another rule that we do have would be about the product to a power rule. What does that mean? Imagine that you have a case that instead of just a number, you do have the multiplication of two numbers inside your parentheses. What does that mean? Look at this one. You do have A, B. By the way, this is something that you have to know, or at least you already know just in case. A, B means that A multiplied by B. When we have letters in mathematics, each of those letters means one number. They are not going to be considered with each other. A and B, they are not going to make one number. There are two different numbers. And when you have AB, actually means that A multiplied by B. So imagine a case that I do have A times B, or AB to the power of n, and I would like to simplify it because I would say that, okay, it's a little bit hard in order to have, for example, 4 times 3 to the power of n. Okay, that would be so hard for me. So I would say that, okay, you can do something about it. Instead of just keeping it this way, you can just divide these two numbers, divide them from each other, not do the division. Divide these two numbers to different parts or different terms, and after that, you still have to keep the same power. Imagine that I do have a point, 3x, by the way, this one is x, okay? 3x to the power of 2. And I would say that use the product to a power rule and separate these two numbers. You can do that, 3 to the power 2 and x to the power 2, whatever is that. And you can keep it as 9x squared. By the way, this x or any other kind of wording terms are related to algebra that we will talk about it in future works when we were talking about the linear algebra and nonlinear algebra. So don't worry about it. This is not our own focus right now. Another rule that, like the product, we do have the quotient or we do have a division to a power rule. It means that we do have the same scenario, but this time those numbers are getting divided. I do have A divided by B. At this point, if I tell you to separate those two numbers, what would you do? You just keep those numbers, but still you have to keep the exponents. Imagine that I do have a 2 divided by 5 to the power of 3. How would you like to do that? How would you like to do the separation? Easy. 2 to the power of 3, 5 to the power of 3. Whatever number that is, and you can find the decimal number. So again, I know these rules are a little bit challenging because maybe this is your first time that you're seeing it. Don't worry about it. We do have so many examples in this slides, and if you have any problem, just comment down below and I would make you another video or we can talk about it together. So let's talk about some special moments, some kind of special things that power has. Base to the power of 1 is equals to the base itself. What does that mean? Any number to the power of 1. Again, let's look at the definition. A to the power of n means that a is multiplied by itself n times, right? But when you have a to the power 1, what does actually means? A to the power 1 means that the number is just by itself. The number is alone. Are you agree with me that a to the power 1 actually was the a itself? Because we know from a to the power 1, 1 means alone and a is alone. So any number to the power of 1 or to the exponent of 1, sometimes we would say that the exponent of 1, sometimes we would say that the power of 1. Any number to the power of 1 is just itself. On another hand, we do have another interesting rule that a to the power of 0 is 1. So maybe some of you would say that, what does that mean? I don't get it. First of all, this is a rule. Remember that. But for some of you that are a little bit curious that why a to the power of 0 is equals to 1, let me give you an example. Imagine that I do have a scenario. 2 to the power of 3 divided by 2 to the power of 3. Okay? Obviously, this one would be 8, this one would be 8, and I know it's just 1. But I would like to see that actually 2 to the power of 0 is 1 as well. You remember that from the division rule or the quotient rule, we had what? If we do have a scenario that the base are the same, at this point the powers are also the same, but we just keep the fact that we know bases are the same. I would keep the base and I just subtract those exponents or power from each other. So I do have 2 to the power of 0. I already knew that the 8 divided by 8 was 1, so 2 to the power of 0 is also 1 as well. So this is a rule, this is a simple example to show you that why 2 to the power of, or any number to the power of 0 is 1. So let's see some examples. 5 to the power of 1, 5 itself. 9 to the power of 0, again, any number to the power of 0 is 1. 100 to the power of 0 is 1. 1 to the power of 100. So this is another, I cannot say it's a rule, but it's a fact. What does it mean 100 times multiplied by itself? You have 1, multiplied by 1, multiplied by 1, multiplied by 1, and keep going until 100 times. It's still 1, right? It doesn't matter how many times you multiply 1 by itself. It's just 1. So the important note about this one is that maybe some of you would curious and say that, okay, what is 0 to the power of 0? So 0 to the power of 0 is one of those undefined moments that we do have in math. Maybe in advanced mathematics, they do have some kind of definition about that. But in Math 101, we just consider it as undefined. Another undefined moment that if you want to see some error but interesting, just consider 4 divided by 0, use it in the calculator, and you would see another error. So we were talking about positive exponents, 0 and 1. What about negative exponents? Just before talking about that, I have to make you familiar with the concept reciprocal. What does that mean? Imagine that you do have a condition that you have 1 over 2. We know that is a fraction, right? Reciprocal means that you are changing the position of numerator and denominator. This is a mathematical way to do something with that. Why we're doing it right now, we don't know it yet. But this is something that is there. So it means that at this point, if I ask you to change the position of numerator and denominator, you would have something like this. 2 over 1 or the 2 itself. In order to show that how we can have the reciprocal, or in order to hint someone that we are doing reciprocal, we use the power of -1. It means that if I give you a question and I would say that 1 over 2 to the power of -1, actually I mean find the reciprocal of that. So this is the definition of negative. Whenever you see negative number in power or in your exponents, immediately you have to think about reciprocal. For instance, when I do have a to the power of -n, what does that mean? Means that actually I'm trying to find the reciprocal of a to the power of n. So when I'm trying to find the reciprocal of this number, obviously I can, because there is no number on the denominator, so I can write it 1 because it doesn't going to have any effect on the final number, right? A to the power n divided by 1. And if you want to find the reciprocal, it would be 1 divided by a to the power of n. Okay? So let's see some examples out of it. I do have 2 to the power negative 3. Actually means that it is 1 over 2 to the power 3. Remember, keep the negative 1 out of your sight, and after that, find the reciprocal. Negative 1 means reciprocal. So 1 divided by 2 to the power 3, 1 over 8. 10 to the power negative 2 is 1 divided by 10 to the power 2 is 1 divided by 100. And 5 to the power negative 1 is just 1 divided by the 5. So look at this example because sometimes it would be a little bit confusing for you. You do have 2 questions. The first question is this, negative 2 to the power 4, and another one is negative 2 to the power 4. So you have to look at it that what is going on in this question, right?